Good morning, AOBI. This is Mr. Dunning. Stand by. I have a math lesson for you. See something like this, you're not used to seeing it. So what does that mean? Well, it's easy, okay? It's really easy. The top number is power. Bottom number is a root. Let me say that again. The top number is a power. The bottom number is a root. So if we wrote that this way, there's our root. There is our power. The square root of 4 is 2. 2 cubed is 8. Yesterday, we looked at how much of the pizza you ate. And when we looked at that, we discovered that there's a way to calculate that. What you need to do is compare this to 360. In this example, you ate 1/6 of the pizza, because 60 goes into 360 6 times. So this is 1/6 of the area of the circle. Now, in order to come up with a number here, we need a radius, because we're getting 1/6 of the whole circle. The area of the whole circle is pi times the radius squared. In this circle, that will be pi times 12 times 12, the radius squared. And we want 1/6 of that. So the area of the sector is going to be pi 1/6 when we compare the whole circle to 1/6 of the circle. Well, we get 1/6 of the whole circle. We can do a little bit of reducing here. The 6 will go into itself once and into this 12 twice. So we've got 24 pi. That's the area of this sector, 24 pi. We're going to do a few more examples here. This was just a kind of tickle your mind and remember what you did yesterday. In example 1, this angle is 45 and the radius is 10. So what we're looking for is how much of the circle is in this sector. We need to compare 45 to 360. There's 8 45s in 360. So now we need to put in the radius squared, 10 times 10. The area of the sector is going to be 1/8 of pi times 10 times 10. And once again, we're fortunate because we can do a little bit of reducing here. 2 will go into 8 4 times, and it will go into 10 5 times. 2 will go into 4 twice, and it will go into this 10 5 times. So our final answer, 5 times pi over 2. 25 pi over 2. The area of this sector, 25 pi over 2, or 25 halves of pi. You could say that either way would be correct. In this example, we've made the angle 72 and the radius 15. Let's fill in the blanks. 72 over 360. That's 1/5. So this sector is 1/5 of the whole circle. Well, the whole circle is pi r squared, which is pi times 15 times 15. The area of the whole circle. The area of the sector is going to be 1/5 of pi times 15 times 15. Again, we see that we can do a little bit of reducing. 5 goes into itself once, it goes into 15 3 times. So the area of the sector will be 3 times 15 times pi, or 45 pi. In example 3, we've made this angle 36 degrees. So our procedure compared 36 to 360. "36 will go into 360 10 times. So this sector is 1/10 of the area of the circle. The circle itself is pi times the radius squared. So we want 1/10 of pi times 6 times 6. And again, we can do a little bit of reducing. Look, 2 goes into 10 5 times, and it goes into this 6 3 times. At this point, we're done reducing, so we've got 18 pi over 5. 18 pi over 5. The area here of this sector, 18 pi over 5. In example 4, we're tasked with finding the area of this segment. Now the area of a segment will be the area of the sector it's in minus the area of the triangle. So to find the area of this little black piece, we first have to find the area of the whole sector. Now we know how to do that. The area of the sector will be (60) divided by 360 times pi times the radius squared. So, in this example, we have 1/6 of pi times 10 times 10. Again, we can do some reducing. 2 goes into 6 3 times, and into 10 5 times. So in this example, we have 5 times 10 times pi over 3. That would be the area of the sector. The area of this triangle should be easy because we have a 60-degree angle here. And when we split the triangle to get our height, that creates a 30, 60, 90 triangle. Now what we know is the radius is 10. In this triangle here, that's the hypotenuse. And I know that the side opposite the 30-degree angle, this piece here, is half of that. So this piece is 5. Side opposite the 30-degree angle is half the hypotenuse. This piece, h, is going to be our multiplier, 5, times the square root of 3. Our ratio in a 30, 60, 90 triangle, 1, 2, square root of 3. With a multiplier of 5, there's 1 unit of 5, 2 units of 5, and the square root of 3 units of 5. So, the area of the triangle, half the base is 5, times the height, 5 times radical 3, Now we can plug that in and find the area of the segment. It will be the difference between this and this. Now, I warned you all that some of these would look kind of weird, but that expression right there, 50 pi over 3 minus 25 times radical 3, is the area of that little segment. We needed to know the relationships in a 30, 60, 90 triangle in order to find h. Let's do another one that involves a triangle that we should know. In example 5, we've got this triangle and this sector and that segment. The central angle is 90. The radius of the circle is 6. So the area of the whole sector is going to be 93/160ths of the whole circle, which is pi times the radius squared. Once again, we find ourselves able to do a little bit of reducing. 2 goes into 4 twice and into this 6 3 times, but 2 also goes into itself once and into this 6 3 times, leaving the area of the circle sector 9 pi. 9 pi. Now the area of the triangle. Well, this triangle is easy. This is a right angle. That's a base, that's a height. So the area of the triangle is 1/2 the base times the height. One half of the base, 6, times the height, 6. Once again, we can do a little bit of reducing. The 2 goes into itself once, it goes into this 6 3 times. Answer, 18. So the sector is going to be the difference between 9 pi and 18. Nine pi minus 18. By the way, you could simplify this by factoring out the 9, and you'd have 9 times pi minus 2. That works. This is correct. That's simplified. Also correct. In example 6, the crowning achievement of putting this all together is to get this funny looking shape here. Kind of looks like Hey Arnold's head when he's taking a nap. This area. But all is not lost here. Let me show you what you need to do. See, there's actually, in this picture, 2 identical segments. And we only need to find one of them and then multiply that by 2. So let's get rid of the part of the picture that we really don't need. And remember that whatever answer we get for a segment, we need to multiply it by 2. Now we've got this picture down to where we're going to calculate this segment and double the size. This is a 90-degree angle and radius of 10. So right off I know the area of the triangle. The area of the triangle is easy because that's a right angle. So the area of the triangle, 1/2 of 10 times 10, or 50. Now, how about the area of the sector? Well, this sector, 90 degrees, that's 1/4 of the circle, and the circle's area pi times r squared, but we don't want the whole circle. The area of the sector is going to be 1/4 of this. And again, we can reduce. 2 goes into 4 twice and into 10 5 times. This 2 goes into itself once and into this 10 5 times. The answer, 25 pi. I hope that you're noticing something here. Before I multiply numbers, I just string them out so that I can see these kinds of things. It makes your calculations so much easier. So now, the area of this little segment, what we set out to find, 25 pi minus 50. But remember, to solve this problem, how many of these do we need? 2. So, the area that we need is going to be 2 times that, or 50 pi minus 100. Today, in review, we looked at yesterday's work, reviewed the area of sectors and segments, and how you calculate the areas of both. Today, we did our crowning achievement, marrying this with 2 overlapping circles to find this kind of football-shaped piece. That was fun. Before we leave, I want to remind you all that all late work has to come in to me by the end of tomorrow, or the zeros that I've been carrying will become permanent. That's going to seriously damage a lot of people if they don't get that work in. As always, you've been a great audience. See you tomorrow with answers to the quiz.